Hello everyone, I am Jawad. So today we are going to discuss about the vCenter installation and its ecosystem. So last time we already discussed about the ESXi installation, then we go for the DNS installation. Furthermore, we move to the DNS configuration, and after DNS configuration, we also do the prerequisite, which was NTP2 for the vCenter and the ESXi. Right now, we are going to start the installation of the vCenter. But before that, we want to understand how all the system interact with each other. Then we'll deep dive to the installation steps. Okay. So let's start. What is a vCenter? vCenter is basically the centralized management tool for the VMware vSphere environment. What is the purpose? It basically enables the management of multiple ESXi hosts or virtual machines and virtual storage and networking from a single host. Imagine you have 10 ESXi hosts and 1000 of virtual machine running in different ESXi hosts. So you have to manage each one separately, right? But what the vCenter is doing, it's providing you a single web page from where you can manage all those tons of hosts and hundreds and thousands of VMs, storage, and networking from one single console. What is the features is basically that's what it simplifies the data center administration, and it's a scalable and secure infrastructure. And as I said, it is centralized from one console. You are doing everything, and proactive management means you have view all the data center activities and resources from a single dashboard. So this is the beauty of the vCenter. Okay, so let's discuss about the traditional SEN because we are going to discuss about the vSEN, which is in the vCenter. Okay, what is traditional SEN? A dedicated high-speed network that connects servers. Means servers here means the compute server. Okay, which has the applications running to the storage devices. Key feature of the traditional means delivers high performance and scalability for storage operation, and they also supports complex storage networking with features like zoning and LUN. Okay, basically here it is totally separate storage, and the servers where the applications are running are separate. In the traditional, you don't have the hard uh, needed on the compute server. You can definitely you have the hard disk, but for the storage or for you have in the separately. Okay, what is zoning and LUN? Zoning basically controls which compute server can access to the storage network. Storage network, we have the controller. We will discuss about it. Think zoning as in like an office with multiple departments, and only employees from the same department can see the specific area. So, for example, like a technical team cannot enter to the finance team unless they have a special permission. Zoning groups basically groups are together to control access at a broad level. If you're not part of a zone, you cannot initiate communication with the device in that zone because in the storage area you have many what you say array of disk and controller. So the zoning will define that okay, you can access that storage controller or not. So this is now we go to the LUN, which is logical unit number. Now LUN is a specific slice of the storage that a service can access. What do you mean by the slice? I mean a specific disk into the array of the disk, which is controlled by the storage controller. It is like a unique ID for a chunk of storage space. Okay, so again, think like a department. As we said, that department is as zone. So within the department, there are many cubicles. You can say. Therefore, each employee, here employee is a server, is assigned to the specific cubicle, which is LUN. So they can work in the same way. In the someone, sorry, what I mean to say, they can't work in someone else's office until given access. So basically, they are mutually an exclusive. What I mean to say is that they can work together. In other words, you can say zoning is like a security pass that lets you get into the building and determines which floor you can visit. While LUN are like a keys of the individual room, or you can say the cubicles, and both are necessary. Zoning makes sure that the right compute server can get the right storage areas, and the LUN makes sure that only the storage space, the specific disk, is assigned to them. Okay, what is the the typical use case for the traditional SAN used by large enterprises that have extensive storage requirement? And it's beneficial for the organization that requires separate storage for performance or security. So it's depend on the customer. Suitable for application that need guaranteed fast access to block storage. Okay, as I told you that there are servers which are running application are called compute servers. So how the traffic will flow? The traffic flow will go to the host bus adapter. Where is this stored? It is stored in the compute server itself, which is a slot like you stored in the PCI slot of the LAN adapter or other. Similarly, you store the host bus adapter there, and that will be connected to the fiber channel cable, and that fiber channel will be further connected to the fiber channel switch. It's just like a networking switch, and that switch will again be connected via fiber to the storage controller, and that storage controller is basically, you can think as a zoning, its control zone. And then further in the storage area controller, you have the disk shells and the storage media, which can be controlled with the help of the LUN, logical unit numbering. Hope it's clear, the traditional SAN. Now we come to the virtualized storage SAN. It is an enterprise class storage virtualization technology which enables you to pool disks from multiple ESXi hosts to create a distributed shared integrated database. Like before, it was separate, right? But now what happened? Many ESXi hosts you are running separately, and each one have many hard disks. And what will happen? It will create a cluster of all the hard disks located in different places, and it will show you as a one cluster, one logical unit. And it's the core component of the VMware's hyperconverged infrastructure solution. So what is the hyperconverged storage? It combines the compute and storage, as I said, in a single hardware stack. Instead of separating it, it's integrating into the single stack. This integration simplifies the data center operation and reduce the hardware footprint. Software defined storage. Unlike you need a separate software to configure those software storage arrays and vendor specific, but here you just need one software, and it's fully software defined, which means storage services are managed and provisioned through a software. That's what I said. It's not dependent on the proprietary hardware, and its dynamic scalability mean you can just add or remove hard drive in the ESXi host from the cluster, and it will automatically be visible in the cluster. When you should use, when you want to compute storage and network in a single platform. So this is the beauty of the virtual storage area network, but it depends again on the customer. But this is, I would say, it's very it's featuring both of the feature in one solution. So it's better to use vSAN. Okay, VMware vSphere. What is vSphere? You will see a lot of terminology. This one, that vSphere is not a separate software. What it is basically it's a platform, and it consists of ESXi and vCenter. So both of these multiple EXI and vCenter, when they are talking about vSphere, it means they are talking about this environment, ESXi and vCenter. both of them. And what is the key feature of the VMware Sphere? It's enable the centralized management of the virtual environment. Of course, it's all virtual environment where you have the ESXi running, and to manage those ESXi, you have vCenters. Okay, and I forgot, I think, to tell you the VM center is going to be a separate VM, um, which is, but it will be needing ESXi. Uh, and furthermore, the key feature you would say that provide a robust ecosystem for running virtual machine. And typical use cases is deployed in the data center that require high with availability and resource optimization, and also preferred in the environment that needs seamless virtual machine mobility with the help of the vMotion and other feature we will discuss. Sorry, I already mentioned above. It's mentioned high availability, DRS, and vMotion. What is vMotion? Is basically you can seamlessly migrate the one VM from one ESXi host to another. Similarly, distributed resource scheduler is for the load balancing. For example, one application is installed in two VM, and you can do the load balancing with the help of the DRS. High availability is like one VM, you make it primary server, the other one make it a standby VM, and if somebody fail, it can immediately switch over to the other VM. This is high availability, and this is what we say it's seamless virtual machine mobility. So this is the beauty of the VMware Sphere environment. Okay, let's go on to the vSphere cluster and storage. What is vSphere cluster? It's a collection of, already said that what you name is cluster. Cluster is basically the ESXi host and associated virtual machine within a shared resources and a shared management interface. Why shared management interface? Because you have one, what do you say, vCenter to manage multiple hosts. When you group hosts into a cluster, you enable features like vSphere, high availability, vSphere distributed resources scheduler, and vSphere vSpin. That's what we already discussed. And let's again hear the comparison in a table to be more clear. We already discussed the differences. The traditional SAN and the VMware SAN is one is hardware defined while the other is software defined. Storage integrated, uh, it is separate from the computer resources in the traditional SAN, and it is integrated in the vSAN. Similarly, the cost is higher in the traditional SAN, and the management have different tools for the traditional SAN, while it is in the VMware, it is just managed with the vSphere interface. Okay, deployment complexity is more in the traditional SAN, while it is very simple in the VMware vSAN. It is less flexible, the traditional SAN, and it's more flexible. High performance are for both, but one is dependent on the hardware, while the other is software optimized. Both are highly available, uh, and the use case, large enterprises are mostly used with whose requirement is to use dedicated storage. Separately, they use the traditional SAN. All right, hope this is clear. Now we need to prepare the environment. The environment for the tiny, which is equivalent to the 10 host or 100 VMs, it is usually two CPUs and memory is 10 GB and storage is 250 GB. So we need to verify that we have this minimum requirement or not. I have already this all requirement fulfilled. And then you need to plan that I already said that you can plan tiny, small, medium, large, or X large. We will see this window when we will doing the installation. And then the prerequisites also include DNS configuration, which we already did in our previous video. If you have not seen it, kindly go through it. And then we also need to make it sure it is NTP configuration is there, server is there, so we can just use that as an NTP source. Now what we need to do, we need to mount and deploy. The vCenter installation happen in two stages. First of all, you deploy the appliance. You deploy the VM. Basically, you create a virtual machine and you install the Linux machine. But that installation has to happen on the ESXi host. You cannot do the vCenter installation on any, you just start one Blade server and you just install the Linux, and on top of that Linux you install the vCenter. No, it's not possible. It should have a ESXi installed there. All right. So once it is deployed, we will configure further the appliance. Why it is two-stage process? It's to be more controlled deployment. First laying down the appliance VM itself, and then you configure the specifics of the vCenter instance. Then we have VM designed this approach. Why? To simplify the installation and configuration process, ensuring that user can accurately set up the vCenter server appliance with minimal hassle. Okay, we will go, first of all, we will discuss this D switch further. But before that, I will start the installation. Okay. As I said, first of all, mount. This was the first step here. And now the stage, there are two ways to install. User interface, I will use this window, and I am installing using the Windows because I have copied this image on the Windows. And where is the installer? Here is the installer. Here we go. And it will start now. Install. Next. We need to accept it. Otherwise, it will not work. What is the ESXi dot? I have the jnetlab.com. Okay, username, I have to give it the username of the ESXi host where I'm installing it. All right, let us ping ESXi dot ujnetlab.com. It's already pingable because I have already added the DNS configuration in my Wi-Fi. Okay, so you need to also add the Wi-Fi in your Wi-Fi setting if you are using the Wi-Fi. Otherwise, you need to plug the cable. Okay, I will give vCenter the VM name, and the password I will set. This will be the password for the VM of the vCenter. As I told you that this has to be stored onto the same where the ESXi host is installed. Okay. So, all right, this is done. Let's wait. Now this is what I was talking. I will select tiny because I have only one ESXi host right now. Okay, I will enable the thin disk mode. The thin disk mode is beneficial because, for example, here if it is provision 47, maybe it is not utilizing full 47 GB. Maybe it will start utilizing and 20 GB. So as you grow, it will automatically occupy that space. Initially, it will not occupy all the space. So it is more better to use if you have so much hard disk, like maybe 10 tera or more than that, then you can use it. I have very limited 2 tera only. Okay, this is the name. You see, it's automatically detect the VM. This was where it exists. Remember, I will show you if you forgot. What was the password? Okay, networking VM. Okay, this is VM network is here. You can see one management. This is the adapter, which is for the host communication or vMotion communication or load balancing. And this is VM network, which is for the VM's communication. And this is the vSwitch created. Okay. So this is, it automatically detect this one to contact to the external world. This port group was for the to communicate with the external world. All right. While don't forget, this management network is for different purpose. It is for like vMotion, high availability, or storage vSAN. It is used for that purposes, other purposes. All right. Okay. vCenter dot ujnetlab.com. Okay, I will give the IP 192.168.4 dot. What was the IP before I gave? Yeah, 110. 110, 100 is for the 255, 255, 252.0. Okay, 192, 168, 4.1. DNS server, I need to mention 192, 168, 4.105. All right, this is the summary. And once we finish it, the installation will start. It shows you all the summary that what is the deployment detail. The target host is this. VM name is this. This is the storage type. Disk is I have configured thin. What is the network detail? I am using the same network details, same port group, which was in the ESXi host. What is the host name? vCenter.ujnetlab and subnet, gateway, DNS servers. I have given it. All right, and then it will start the installation. It is successfully deployed. Now we will proceed to the stage 2. Stage 1 is completed. I will make it synchronize from the NTP server, which is 192.168.4.105. Okay, SSH enabled. NTP server is this, correct? Oops. Unable to do it from the NTP. Let's see why it is. It was working fine. CTL. It was okay. I think it's somehow it get stopped. I don't know why. It was already done before, but somehow it. Let's try again. It usually takes some time, so maybe it will give again error. Let's see. Let me see. Okay, it's done. Let me see if the DNS server is also not stopped. Status. Yeah, that one is already running. Yeah, it's fine. There's no issue. Okay, we will give this default name vsphere.local. Why we will give this name? Because VMware usually use its own SSO domain behind the scene. You can use this, you can join to the existing domain, but for that you should have Active Directory for Windows ready. I don't have that one ready. The other way is you configure the LDAP server, and but the LDAP server, this installation, this option is not designed for the LDAP. Open LDAP, which is used in the Linux, is not designed for that. It is only designed for the Windows Active Directory. So, but anyhow, if you still can use LDAP once the installation is done. You can uh, uh, add the LDAP server, and then you can change the single sign option. You can associate to that one. So if you want to have a video on that LDAP server, let me know in the comments, so I can also make the video on that one. All right, I will give the password. Okay, I cannot pause in the middle. So the stage 2 will now start. Yeah, it will take some time. Okay, the installation has been completed. We can log in here. Now we will launch to the vSphere client. Now you can see vCenter VM is ready. And now we need to create the data center. I will give the data center my DC, my data center. Here you go. And now under my data center, many ESXi can come. Add host. I will give the host name ESXi dot ugnetLab.com. Okay. Yes. Lockdown mode. I will put it disabled. VM location. Okay, now this you can see here, it's added. So, and now immediately you can see now under the I have my top on the top level. Sorry, on the top level I have vCenter, and on that under that I have my data center, and under my data center I have the first ESXi host. In this tree, I can have multiple ESXi hosts, and I can have multiple VMs under that ESXi host, and that will be managed from the vCenter. All right. So now the installation has been done. If now we will move to, we finish this part. We have configuration and we started. Now let's discuss about the D switch. D switch is a provides centralized network management for a vSphere environment, offering more features and capability than standard virtual switch. The main feature, I would say, it's span on multiple ESXi hosts. So if you have multiple ESXi host here, one vSwitch will serve for all the ESXi host. You can resemble it like in a building. You have multiple floors. So before, when it is there was no vCenter, just imagine, then on each floor you have to have separate switches on each floor. But with the help of the D switch, you will have one D switch, and each port will be connected to the that switch. So in this way, it is centralized, and every floor is now get connected. Similarly, ESXi host, this like ESXi host. Let me log in here, and I show you again what I mean. Come on. I don't know why it's not level 2. No. Okay, what I mean is, so say you see one vSwitch is there. So you can have multiple vSwitches, of course, but what I mean to say, under host, you have separate vSwitch, and this will serve only this ESXi host. But what if I have 10 ESXi hosts? So in order to serve those, you have this D switch. Sorry, let me go here. All right. So basic difference is, I know other feature which I like is there is a trunking feature. You can make a port trunk. While this feature is not available in the vSwitch, you can do it, but in a separate way. You have to assign VLANs to each port group, but not like you can assign a range of VLANs to the port group. This is the beauty of the D switch. Management scope, as I said, it's per host, while it is across all hosts. Centralized is D switch, while V switch is not. You don't have the capability of load balancing, networks resource pooling, and private VLANs in the V switch. Port mirroring limited, and traffic shaping is there on both of them, but more granular control you have on the D switch. And net flow support you have on the D switch is the beauty, and is more scalable in D switch. And use case for the D switch is used in the large environment, while V switch is used in the small environment. Our will also cover up the V switch, but this is just for the learning purpose. So that's why we are doing the D switch. Okay, what is the traffic flow? How the traffic will go from the using a D switch in the vSphere environment. So first of all, there will be a physical network. Don't worry, you will see visually also. It will enter to the, and then from there it will, the traffic will be originated. Then it will go into the ESXi host with the help of the physical NIC, which is called vNIC 0 or vNIC 1, depending. If you have 8 ports, so it will start from the vMNIC 0 till vMNIC 7. Alright, once it is entered in the physical, it will go to the uplink of the D switch, which is a virtual switch, actually, distributed switch, or a virtual switch you can say, but virtual switch terminology is mostly used in the ESXi host. But in nature, it's also a virtual switch. So it's not a physical switch. That's what I meant to say. So vMNIC is assigned then to the uplink to the D switch. From this is where the physical connectivity is bridged to the virtual environment. This is the third step. Now the fourth step, it will of course enter into the D switch, and it operate across all the hosts in the data center. Okay, so once it is entered into the D switch, it will further go to the port group. Remember port group in the first lecture in the ESXi, we said that it's a template, and all the policies, all the shipping and apply whatever is gone to the VM level, port level. So it will arrive here, and then once it arrive here, it will go to the virtual NIC port, and then finally it will arrive to the VM machine. I notice I skipped the sixth step. Why? Because this is the general communication for the VM. But what if you are using that feature? You are doing the management of the host itself. Host, when I say, is ESXi host, or I am doing some kind of data storage, or I am doing some kind of vMotion or other functions. Then I need a VM kernel adapter for that, and then if case in that case the VM kernel adapter will be used. Okay, now you see here, for example, we have four blade server. This is the outer line, this is the blue, the sparkling line is for the blade physical server. Okay, inside each physical server we have ESXi host installed. Okay, one, two, three. Orange color is the ESXi host. And inside each ESXi host, we have, let's say, one vSwitch each in the black color. And we have VMs, all right. And we have this, you can see here, physical NIC, all right. And this NIC is connected to the external one. On the fourth server, we installed the vSwitch also, the ESXi also, and we also installed the D switch. And that D switch will be basically connected to the port group. And that port group will be connected to the VMs, and that VMs are residing in different ESXi host. All right. Here it can be also a VM, but I'm just giving an example here that here is VMs 1, 2, 3, here is 1, 1, 2, 3, and similarly, and those all ports will go to the D switch. So this D switch is basically reflected over here also, over here also, and over here also. Okay, so it is reflected over 4. It is acting like it is existing in all the switches. How it's reflected, we will see in the window here. All right, we go here. First of all, I will go on to the ESXi host. This is our ESXi host. All right. Here we can see VMs. You can see here virtual switch is there already. All right. Okay. So I will come in the networking section. Then I will come here and I will come new distributed switch. I will give the name of D switch. Let's say I will leave it as blank. It's fine. Next. Select version. Number of ports. Okay. I don't want to create a default group. Okay, so now this D switch is created. Okay, what is created? If you see this picture, I have created this D switch. Now I need to assign this D switch to some host, right? This has to be mapped to some host, right? So it can be reflected onto, but right now I have one server, so I will assign to this host. Okay, I will go here, right click, add networking, Sorry, not here. This is for the adapter. It should be here. Configure, add manage host. Okay, and I will add the host. You see it's automatically pop up. Which one? You can, for example, if there are 4 servers, it will automatically pop up here, and you can just reflect that one to all those ESXi hosts. It is showing which one, assign uplink. All right, I'm not assigning right now anything. I can assign, no problem, but I will tell you what I mean is to say later on. I will assign this uplink 1. This is the physical adapter. Remember in the presentation I told you that this is the physical adapter, and this switch is used by this switch. What is the port? Because remember I configure only 4 uplink port in this one, and I will go here. Is giving the warning. Having warning sign might lose network. I'm not doing any kind of migration, so don't worry about it. My focus is just to right now, what as I tell you in the diagram, I'm just adding this port group, right? Sorry, I am adding this host right now. This switch. Okay, just click next. Okay, it's asking that I should assign to something. VMK0 is the old adapter which I am going to use it. I will select next because I don't want to add actually the uplink now. I'm not migrating anything right now. Number of hosts is added 1 because my focus is just right now to add the host. Sorry, map to this the switch to this host. All right. So now this D switch is added. Let's go. Nothing is there, right? You can see uplink 1, 2, 3, but you can see there is nothing there. I can add port group and I can give data port group, static binding, and elastic. Elastic means you can increase the number of ports later on, but for me it's fine. VLAN, I will put VLAN trunking and I will choose this one like that. Maybe I can choose 20 ports. Now what I am doing this one, as per this diagram, I am creating this port group so it can have many ports, and those ports can be assigned to the VM NIC card. All right. This VK0 is the adapter, which I told you already that this adapter is only used when you are using for the ESXi host management, vMotion or vSAN or load balancing. For these kind of purposes, you need this VK0 to create it. It's automatically created by default when you install the ESXi host. I will create accept. Don't want to reject. In ingress, disable. I don't want any kind of shaping. Net flow is disabled. Block all port. Yeah, no, I don't want to block all the port. If I select yes, it will block all the port. Next. Now the port group is ready. You can see the data port group is ready. Okay. And if I see here, refresh. This is I'm on the ESXi. Okay. You don't need to go here actually, but I'm just going to show you here, nothing else. Still, it's not reflected here, but this is right now edit. Okay, let's go on to the presentation. This port group is added. We have mapped this D switch to the host, ESXi host. Now what next? You can assign this physical NIC to this D switch uplink. But right now, one of our NIC is already used for the management purpose. What I mean to say, if I go here, select this one, add networking, physical adapter, it will ask which switch you want to it. I say, okay, I want to do D switch. Okay, next. And it's, you see, I created initially D switch with 4 uplink, and it is asking which NIC, which port you want to assign with the physical port. Okay, imagine I will go back here. This D switch has 4 uplink port, 1, 2, 3, 4. And now this one of the port you want to assign to which physical NIC. All right. So I will go here. I will click plus add. It is listing me how many? 7. The 8th one is already utilized. Where? It is utilized here. VM network, VM network, you see VM0, or you can say here VMK0. VMK0 is what? Kernel adapter. Kernel adapter, as I told you, is for the management. Management of what? For the ESXi host and other purposes like vMotion or vSAN. Okay, storage if you have external storage. So this port, this adapter, no, sorry, this adapter, VMK0, or it can have multiple adapter. So this adapter is usually only come into place when you are talking about the management of the ESXi host. Right now it's already managed with the help of which port group? This management network port group. Not for this management port is only for the ESXi management. VM network automatically created by the ESXi for the VM's communication. So this one I want to highlight the difference so it can come. Right now nothing will happen. Nothing will happen because I'm just showing as a demonstration purpose. Why? Because you see it is down. I have the 8 NIC, but they are not connected to any switch to external world. But anyhow, you can just, you see here automatically come up. But when I will go to the 2, it will not show me the VM NIC because it's already assigned. You see, it is starting from 2. Now next, and finished. So if you go on to the topology, I'm forgetting where the topology, sorry for that. No, it's here. Yeah, here, topology. Okay, you see now we have one uplink port which is assigned to the, if I see here, it is using this host NIC, and there is no adapter here, and this is for the data. Right now what will happen, the VM network is there. VM network is created, whatever the port group is created, it's actually created on the ESXi host. But the VM network uh, group, I'm not going to migrate to the D switch. I will remain as it is. Why? Because I need two adapters for migration. Right now here it is one adapter. If you want to have uh, migration, it is better that you have one more adapter here, and that one more adapter will be bind to one port group, and that port group will be bind to another physical NIC. So benefit, what I mean to say is to say right now, if I go here, right click, add networking, VM kernel network adapter. Once I did it, it will ask which network you want. I will say, okay, I want on data. All right. So with this help, what will happen, that another VMK I'm creating, another adapter I'm creating here for, let's say here, and that will be mapped to that port group. And then this port group will be further map. You see what I told you before, that this is not for the VM's communication. It's only for the vMotion, fault tolerance management, vSphere, vSend, these type of feature it is used. Okay, then I need to give the IP. All right, and then this is how it works, but I'm not doing it here. What is the benefit it will happen if I create an additional adapter? It will definitely bind to the separate physical NIC. The migration will be very smooth because the VMs currently is already mapped. You see the VMK0, the VM network, not this VM network. What I mean is to say the management network is already bind. This port group is already bind to which one? To the V switch. So you cannot just migrate like that to the D switch. I want to migrate this port group to the D switch. So in order to do that, you should have an extra port running up, physical up. Why in my case it is needed? Because this management is actually talking to the external world onto this port, onto this VMNIC 0 port. And I need one more extra here to communicate to the external world for the management. So if I have one more port, I will add one more port, VMK1, and then I will do the smooth transition from this management network to the D switch. Then it will, and then automatically once this transition is done, the V switch will be it will not show anything to you, and it will be transitioned to the D switch. So what is I'm going to do? I'm going not to do any transition here. I am just going to use the D switch for my own where it is here. Here's the topology. Right. Right now you see it's only uplink. What I'm you can see here there is no VMs assigned here. Even but here you go, if you go here onto the VM network, you see you can see two VMs under the port group name, which is called VM network. But here on the left you did not find it. But don't worry, in the future we will add more VMs, and that will be connected to the D switch here. You will be thinking, if the red ports are connected to here, then how they are going to communicate with the external world? No worries. They can at least communicate internally over the D switch, and if they want to communicate over to the external world, I will use this port group. Which port group? The existing vCenter, this VM network port group. But for the VM to VM communication, like this vCenter, I will add 3-4 more VMs in the future, and I will show you that those communication will be happening on the D switch locally. For that, I do not need the external uplink. Hope this is clear to you. Let's go further. What I explained to you. I have just make a note for you to explain again whatever I have explained to you. The first, it will go to the external network, and then external network, it will go to the physical NIC. This is the physical NIC. And then it will go to the V switch. In our case, it is a D switch here. Let's say it's a V, but categorically it's a V switch. From the V switch, it will go to the port group, to the big template group. And from that template group, it will go to the virtual machine. And from that virtual machine NIC port, this is the virtual machine NIC port. Okay, this green color. And then it will go to the VM. Okay, I miss again this kernel adapter. As I told you, this is only for the management, as we see in the picture. If this port is only used, this will be basically connected to this wire. I mean to the physical port. This is not here in the picture, maybe it's not clear, but it will be connected to this green line, to the physical port, to this sorry, not green line, sorry, to this NIC, to this purple NIC internally. You will do the mapping here, just like here. Where it goes, I want to make very much clear. You see, it's a mapping here. The management adapter is connected to here. So this is what I am saying here. vSwitch, it will go to the adapter, and adapter will go to the vSwitch port group. What is the port group? This is the port group. And then port group will go to where? To this physical adapter. And then physical adapter is this here, and then it will go to the external one, which is the cloud here. Example VM on the ESXi host, let's say, you have the VM on the ESXi host and it want to communicate with the ESXi host 2, which is VM here. So remember this D switch is now I have added onto this ESXi host, so it will be here. It will not be here. So this traffic will not go to this NIC, but actually it will go to this VM will go to that port group, and that port group has the uplink, and that uplink will be connected to the NIC. And this way, from this NIC, it will go to this NIC, and from this NIC, it will go to the port group, and then from port group, it will go to the it will go to the D switch, and from D switch, it will go to the port group, and then internally, it is mapped to the VM. This is how it's getting communication. I hope you enjoy this video. Please don't forget to like and subscribe. And if you have any question, you can put in the comments.